This video is the solution to number 36 in chapter 27. The question asks us to find an equation for the electric field that goes through that red dot. Now we know that the distance between the two infinite lines of charge is d, and that the height of the red dot is y. Using this information, we can go about solving the problem. First, I drew my electric field lines through the red dot. From the positively charged rod on the right, I get an upward to the left arrow, and from the charge on the left, I get an upward to the right arrow. After looking at this and breaking it into components, I see that there's an ERX and an ERY, as well as an ELX and an ELY. Looking at this, we can see that the sum in the x direction is going to cancel, so it will equal 0. However, this is not the case for the y direction. The sum of the electric field in the y direction is ELY plus ERY. Now, using some basic trig, I've changed ELY and made it equal to EL times sine of theta. And the same thing for ERY. Now, also using some more basic trig, I've plugged in y over square root y squared plus d squared over 4 as my sine theta, and I know that E for an infinitely long charged rod is going to be 2 lambda k over r. So plugging in and substituting, I find that my electric field equation for this system is 4 lambda times k times y over y squared plus d squared over 4. Now, for part B, we're asked to draw a graph of the electric field line versus y. Taking a look at our equation in part A, we can note a couple things. E equals 4 lambda k times y over y squared plus d squared over 4. By rearranging this equation, we can see that on the left we have constants, and with the exception of d squared over 4, on the right we have variables. So if we simplify this equation a little farther and plug in, say, d equals 1, because that's not going to change, as well as 4 lambda times k equals c, we can see our equation gets even more simple. So from this equation, we can sort of guess what the graph will look like. And from there, I found our graph of E versus Y to look like this.